Okay, this lecture is over Module 11 in your curriculum. The title is Switch Security Configuration. So we'll start out as we usually do with why should you take this module. And the answer is to learn about concepts and iOS commands that you can use to keep your network secure. In particular, we'll be talking about port security. We talked about VLAN attacks. We'll talk about how to mitigate those. We've talked about different attacks on DHCP. We'll talk about how to mitigate those. We've talked about ARP attacks. We'll talk about how to mitigate those. And then finally, we talked about spanning tree protocol attacks. And we'll talk about how to mitigate those as well. So, starting out with port security. Basically, you should disable any ports that are not going to have devices connected to them. The rationale behind that is you don't want somebody walking in with a laptop into your communications closet and plugging into an empty switch port and being able to gain network access. So any ports that are not going to be used in your production network should be disabled. Down here they show a couple of commands to do that. You can say you can actually do a range of ports. I don't think we've seen the range command before, but if you say interface range and then actually give a range of ports, in this case FA0/8 all the way to FA0/24. Notice that your prompt will be the interface config mode, but it'll have -range to show that you're doing something to a range of ports. So any command you issue when you have this prompt will affect the range of ports you specified. So in this case, we're issuing the shutdown command on all of those ports. The next thing is mitigating MAC attack or MAC address table attacks. There are different ways that we can do that. We can enable something called port security, and we can limit the MAC or MACs on a port to a certain number of MAC addresses and or specific MAC addresses. So we'll talk about those in upcoming sections. But notice here they're saying port 1 is allowed to have MAC address all A's, port 2 is allowed to have MAC address all B's, and port 3 is allowed to have the MAC address all C's. Here in port 1 we do have the machine with MAC all A's, so that check mark means it is allowed to communicate with the switch. But down here we have bad 01 and bad 02. This is not all B's, so it's not allowed to talk. This is not all C's, so it's not allowed to talk. So that's real quick the basics of port security. Now then, if you want to turn on port security, the way you do that is you go into the particular interface and you use the switch port command, which we've been seeing quite a bit lately. But this time we say port-security. So it said it was rejected because it's a dynamic port. So you go, oops, I need to make it an access port, meaning that there will be end devices there. And then I can go in and say port security. So you need to make sure it's an access port before you do that. Here they're showing you the show command. You can say show port security interface F0/1, which is the port we just did. Port security is enabled. It is in secure shutdown stage, and that's probably the most important information out of that show port security command. Here they're showing you that if you're in the interface command and you say switch port security, and then use the context sensitive help command by putting a question mark, you can turn on aging, you can specify MAC addresses, Or you can say this is allowed to have, for example, 4 at most MAC addresses on the port. And then you can tell it that if that is violated in any way, that you want to go into the security violation mode. So in 11.1.4, they're talking about limit and learn MAC addresses. So here they've gone in and used the context sensitive, I'm having trouble saying that tonight, context sensitive help. And you can see that you can specify anywhere from 1 to 8,192 maximum addresses on there. As I alluded to in the first or second section, you can manually configure these, which means you go in and basically say port security MAC address, and then give an actual MAC address of a machine that is allowed to communicate on that port. Or they can be dynamically learned. So if you have, say there are 3, it can learn up to 3 MAC addresses. Let's see. So here we've gone into interface FA0/1. We've made it an access port. We've turned on port security. We told it at most it's allowed to have 4 MAC addresses, but then we turn around and specify AAAA, BBBB, 1, 2, 3, 4 as a valid MAC address. When we show the interface, it is enabled, it is up. In violation mode, we want to do a shutdown, so that means if we get more than 4 MAC addresses or see more than 4 MAC addresses on this port, we just want to shut down the port until we can figure what's going on. And then right now the MAC address table only has the one that we manually encoded. It has not learned any additional MAC addresses beyond, like I said, the one we hard coded. Port security aging basically is how long we keep information. So absolute is the port is deleted after the specified aging time, not the port but the specific address. As far as inactivity, we can say after a specific amount of time, if we have not seen any activity from a MAC address that is in our table, that we want to remove it. So down here we can turn on static aging. We can specify a time between 0 and 1,440 minutes. We can say whether we want absolute timeout, that means the specific amount of time has passed, or if we want an inactivity timer. So down here we go in, we set the aging time to 10, and we say we want to base that on inactivity. So what happens is if we have a MAC address in our table and we do not see any activity from that MAC address for 10 minutes, we're going to remove that. As far as port security violations, there are different things we can do. Again, we can tell it to shut down, which is going to shut down the port. We can tell it to restrict the port, which means that the counter is incremented and generates a syslog message, but it's going to drop packets from unknown addresses until you remove sufficient number of MAC addresses from the MAC address table, or until they time out and go away. Or we can actually say protect, and in that case the port's going to drop packets from unknown MAC addresses until you remove or sufficient number of addresses time out. but it will continue allowing other ports to send that are already in the table, and it will not generate syslog messages. We may not have talked about syslog before. This is something that was kind of born out of the Unix world as a consistent way to log error messages. So you have different levels like critical, informative, administrator, that type of thing. And then you have different built-in systems like mail and the kernel, different things like that. And then you can add other syslog events. So it sends it to a syslog server, which is going to record that so that you can look at it later if you need to investigate something. So down here, we have a violation mode comparison table. So basically, you can either protect, restrict, or shut down. All these are going to discard offending traffic. Protect will not send a syslog message, but restrict and shut down will. Protect will not count the violation counter, increment it. And as far as shutting down the ports, the only one that's going to shut down a port is if you have violation mode shut down. So that kind of tells you what will go on in the different cases. So here we've gone into the port and said violation mode restrict. So for MAC addresses, we currently have 1. The security violation count is set to 1, so we have a counter as to how many violations have occurred on this interface. As far as ports and error disabled, these are going to be occur when a port is shut down and it's actually placed in error disable. In that case, no traffic is sent or received on the port. Here they're showing you messages where it's telling us about security violations. And then here, if we go in and do a show interface, notice that probably one of the most important things is right here at the top. This interface is down, the protocol is down, and the reason is error disabled. So we have some idea, this wasn't administratively shut down. It was due to a port security violation. So here we've had that port. It's in an error state. If we go in and shut the port down, now it's saying it's administratively down. But then if we turn around and say no shutdown, that brings the link back up and kind of starts over, if you will. There's different ways to check the port security. If you say show port security and do not give any other options, it's going to go through and show you all the secure ports, and then it's going to give you how many MAC addresses we can have, how many addresses do we currently have, how many security violations have there been on the port, and what is the action that will be taken if there is a security violation. In this case, it looks like all of them are set to shut down. Or we can go into a particular port, in this case Fast Ethernet 0/18. Port security is enabled. It's currently up. Violation mode is shut down. So same information we talked about here, maximum MAC addresses, total MAC addresses, etc., but just for a single port. If we go in and look for a Fast Ethernet port, we can verify that the MAC address mode is set to sticky, and here is a MAC address that we have learned and that is sticking to the configuration. We can go in and say so port security addresses, and it will go in and tell us the MAC addresses and what ports they are on. So notice that this says secure MAC address table up there, so that's what that's showing us. 1119 is a syntax checker on some of the iOS commands that we just talked about. You can do that on your own. 11110 is a packet tracer activity that is on implementing port security. It's relatively short. I will be assigning that, so watch for that to appear in Blackboard. And we'll move on to the next section, which is mitigating VLAN attacks. So we talked about a number of VLAN attacks. We talked about spoofing dynamic trunking protocol, DTP messages, so that we can send traffic with tagged with the target VLAN and try to intercept that message. We can introduce a rogue switch or run a piece of software that is emulating a switch and enable trunking, and then what will happen is the switch we're connected to will send us VLAN traffic that we can then try to intercept or read. And then we talked previously about double tagging, where you encapsulate a tagged frame, a VLAN tagged frame, inside another tagged VLAN frame. So it'll go to the next router for whatever VLAN you put in there. It will strip the header off, and then we'll have another tagged frame that will be then sent on to another switch, potentially a different VLAN. So 1122 is how do we mitigate, in this case, VLAN hopping attacks. So what we can do is we can go ahead and disable the dynamic trunking protocol on any non-trunk ports. And the way we do that is by saying switch mode access, which says this is an access port, which means there's an end user device on it, and there's no reason to worry about trunking. We can disable unused ports like we talked about in the first section, and we can also put them in an unused VLAN as well. Instead of using dynamic trunking protocol, we can manually enable each of our trunk lines by using the switch port mode, and instead of access we would say trunk. And like I said, that's used in conjunction with disabling dynamic trunking protocol. And then by default the native VLAN is VLAN 1. We can actually change it to something else using the switch port trunk native VLAN, and then decide what VLAN we're going to use instead of the default VLAN 1. So that's basically what they've done here. They've gone in and said the first 16 ports are access ports. 17, 18, 19, and 20 are also access ports, but they're going to be in VLAN 1000. And then in the case of 21, 22, 23, and 24, these are trunk ports, and they're going to set their native VLAN to 999. So that's just implementing the things we talked about in these 5 steps up here for VLAN hopping attacks. 1123 is a syntax checker on what we just talked about. So they'll tell you what commands or what they want you to do, and then you enable the commands, or not enable, you enter the commands. So you can do those on your own. And we'll move on and talk about DHCP attacks. So here they're refreshing our memory as to the DHCP attacks that I think we talked about in Module 10. So the first that they talk about is DHCP starvation, where you try to fill up and use up all the DHCP IP addresses, and then new machines can't get IP addresses I think they talked about using Gobbler, which uses unique source addresses as one of the attacks. Spoofing attack is where you try to sniff network traffic, get a valid MAC address, and then start using this. And here they're pointing out that this would render port security ineffective because you are using a valid MAC address that has either been learned or that you said is okay. As far as they're saying DHCP spoofing attacks can be mitigated by using DHCP snooping on trusted ports, which we're going to talk about down here. So the scenario we have, I think we've seen this before, you have a real DHCP server, you have some redundancy in your network, you have a client down here who's trying to get an IP address via DHCP, and you have a bad actor or a threat actor that has a rogue DHCP server running. So what you're going to try to do in this attack, if you recall, is see the DHCP request and try to respond faster than the real DHCP server and give out either a bogus IP address or an IP address that you're going to try to communicate with, possibly doing a man-in-the-middle attack. So what you do here is anything that would normally get a message from the DHCP server on the way to get to a DHCP client, you set those to trusted ports. All the other ports come untrusted. So what happens is when this rogue DHCP server is trying to give out bad information, it is on an untrusted port. So it is not going to send or communicate related to the DHCP service. So the steps to implement that is we go in and say IP DHCP snooping when we're in global config mode, so that turns it on for the whole switch. On trusted ports, we go in and say IP DHCP snooping trust, and then we give an interface that we trust. And then we can also limit the number of discover messages that can be received per second. So if somebody's really trying to hammer a DHCP server, that can slow it down. You need to go in and enable this on each VLAN or a range of VLANs. And then here, they're showing you another example. Here we don't have all the redundancy, but we have a DHCP server, a switch, a client. This port is untrusted because we should not be getting any DHCP server activity from this PC. But this one is connected to our DHCP server, so it is trusted. So the way we did that is we went in and said IP DHCP snooping. We went to interface FA 0/1. We turned snooping trust on, so that became a trusted port. And then all the other, we went for the range 5 through 24, and then we said limit these to 6 DHCP per second. And then we turned DHCP snooping on for VLANs 5, 10, 50, 51, and 52. So here you can go in and say show IP DHCP snooping. It tells you it's enabled. It tells you what VLANs it's configured on. And then goes through and tells you whether or not ports are trusted and whether or not their packets per second is limited or not. 1135 is a syntax checker that you can do on your own to practice those commands. and then we'll move on and talk about ARP attacks. So basically what we can do is we can use something called dynamic ARP inspection. And what that does is it tries to deal with the fact that a hacker is going to try to send unsolicited ARP requests to intercept or spoof addresses, to do ARP poisoning, that type of thing. So what we can do is use DAI, which is just the acronym for dynamic ARP inspection. And then what's going to happen is it's not going to relay invalid ARP request, or last module we talked about gratuitous ARP request, which is intended for a device to pre-populate the ARP table, but it can be used in hacking. So you're not going to relay gratuitous ARPs. We can intercept all ARP requests and replies that are on untrusted ports. And then we can check for valid IP to MAC address binding on those. If we find any that are invalid, we can throw those away so that we don't have ARP poisoning. And then we can arrow disable the interface if there's a certain number of ARP packets is exceeded. So if somebody's trying to flood our network with ARP request, we can disable that interface. So here they're telling us to enable DHCP snooping, enable it on selected VLANs, then enable the dynamic ARP inspection on selected VLANs, and then configure the trusted interfaces. So basically what happens is we end up with something like this. Before I think we had this router, this switch, and this PC. But if a, quote, bad guy plugs into the switch, he will be on an untrusted port because it's an access port that's been marked as untrusted. So he will not be able to do anything bad. So this is a dynamic ARP inspection configuration example. So here, like we saw a section or two before, IP DHCP snooping, turn it on for VLAN 10, turn on ARP inspection for VLAN 10, and then on interface 24, set this to trust for snooping and ARP inspection. So we trust that port to be doing DHCP and ARP for us. You can go through and usually you would be checking the source MAC address when you're trying to learn this, but you can actually go through and check the destination MAC, the source MAC, and the IP address to make sure that these are valid values. We can go through and say validate. Let's see, do we have an example down here? Doesn't look like it. But we can validate source MAC, destination MAC, and IP. So they've gone in and said IP ARP inspection validate question mark. So again, the context sensitive help. And then it'll tell you can say dest MAC, IP, or source MAC, followed by a MAC address, an IP address, or a source MAC address. So here they've gone through and said validate source, destination, and IP. And then when you go through and show run and look for the word validate, it's going to say IP ARP inspection validate source MAC, destination MAC, and IP. So that's just showing you that yes, indeed, it did get turned on and it is validating those things. 1144 is a syntax checker on mitigating ARP attacks. So you can do that on your own. and we'll move on to spanning tree protocol attacks. So we talked about this, I believe, in Module 10, but the way you deal with this primarily is port fast and BPDU guard. So port fast immediately brings an interface that is a access port or a trunk port immediately to a forwarding state, so that you don't have the problem with being 30-second or 60-second timeout, like we talked about before. This should only be configured on ports that you know are going to be connected to end devices. BPDU, Bridge Protocol Data Unit Guard, it's going to immediately error disable a port that receives bridge protocol data units. Again, this should only be configured on end devices. Those should not be sending BPDUs and will be disabled right away. So 11.5.2 is showing you how to configure port fast. Again, this should only be done on access ports, which means we have end user devices connected to them. We do spanning tree port fast, and then we make that the default, and then we can go through and basically show the running config, things that deal with spanning tree. So here we see that port fast is the default. It sets an extended system ID. And then down here for interface FA01, which we configured up here, it is switch port mode access, spanning tree, port fast. So we can see the effect of this section of commands that we gave up here. As far as bridge protocol data units, even though port fast is enabled, the interface is still going to watch for BPDUs. If it gets one, it may be accidental, or it may be an attempt to add a switch to the network, potentially a bogus switch, or malicious software pretending to be a switch. So what we can do is, in this case, we went into interface fast Ethernet 0/1, and here we said spanning tree BPDU guard enable, and then spanning tree port fast BPDU guard default. So if we go through and show the spanning tree summary, it's going to go through and notice that port fast is enabled, and let's see, that the BPDU guard is enabled. And there's a couple other things that we haven't talked about, like ether channel misconfiguration is enabled as well. 11.5.4 is a syntax checker on mitigating spanning tree protocol attacks. You can do that on your own, and we'll move on to the last section, which is the module practice and quiz. The module practice starts out with a packet tracer on switch security configuration. It appears to be relatively short. I will be assigning that, so watch for that packet tracer to appear in Blackboard. 11.6.2 is a lab with the exact same name. Typically, if this was an in-person class, of course, we'd do the lab hands-on on real equipment instead of the packet tracer. Since I assigned 11.6.1, that probably means that I either will not assign 11.6.2 or I will assign 11.6.2 to do on the NetLab or something. So we may or may not do that one. The next thing is, what did I learn in this module? You can, of course, go through and read all this. Make sure you understand all of it for the chapter. And then the last thing is the module quiz over the entire module. Switch security configuration, so you can go through and check your knowledge on that. And that finishes up Module 11.